ground fault circuit interrupter, or GFCI, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing to and from an appliance or electrical device. If there is a difference in current, indicating that some of the current is leaking to ground, the GFCI trips, quickly cutting off the power. This happens very fast, typically within a fraction of a second, preventing a dangerous shock. A GFCI does not require a ground to function and provide protection. A GFCI works by detecting an imbalance in the current between the hot and neutral conductors. If some current is leaking to ground or another unintended path, the GFCI will trip, interrupting the circuit and preventing electrical shock. The purpose of a grounding conductor is to provide a low resistance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse, protecting the circuit, clearing the fault quickly. While a ground is not required for a GFCI to function, it's still a good idea to ground if available. According to the National Electrical Code, or NEC, replacement of a non-grounding type receptacle is permitted under specific conditions. Firstly, where grounding means do not exist in the branch circuit, a non-grounding type receptacle can be replaced with another non-grounding type receptacle. Secondly, a non-grounding type receptacle can be replaced with a GFCI receptacle. Thirdly, a grounding type receptacle can be installed where the GFCI protection is provided. Any GFCI receptacle that replaces a non-grounding type receptacle must be marked with the label "No Equipment Ground." Also, the NEC states that a non-grounding receptacle can be replaced with a grounding type receptacle where it is GFCI protected. These are the only ways in which a non-grounding type receptacle can be replaced. The NEC doesn't require all receptacles to be GFCI protected, only those in specific locations that are considered to be at higher risk of ground faults. These locations typically include bathrooms, kitchens, garages, outdoors, and other areas where moisture is present. When a GFCI trips, it indicates that there is a ground fault occurring in the circuit. This can be caused by a variety of factors, such as damaged wiring, wet conditions, or faulty appliances. If a GFCI trips repeatedly, it's important to identify and correct the cause of the ground fault before resetting the GFCI. Using a GFCI tester is a convenient way to check the functionality of a GFCI receptacle. These testers typically plug into the receptacle and simulate a ground fault, causing the GFCI to trip if it's working properly. However, it's important to note that these testers are not foolproof and may not always accurately detect all types of GFCI failures. GFCI testers do require a ground to test properly, but the GFCI will still provide ground fault protection without a ground. It's also important to understand the limitations of GFCI protection. While GFCIs provide excellent protection against electrical shock, they do not protect against overloads or short circuits. These types of faults can still cause fires or other hazards, so it's important to have proper overcurrent protection in place, such as circuit breakers or fuses. Regarding GFCI tripping and still having power, this is not typically possible unless the GFCI is faulty or miswired. GFCIs are designed to interrupt the circuit when a ground fault is detected, cutting off the power to the affected outlet or appliance. If a GFCI trips but power is still present, it's important to investigate the issue immediately and consult with a qualified electrician. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest safety practices and technologies. Electrical inspectors use the NEC as a guide when inspecting electrical installations to ensure that they meet minimum safety requirements. The NEC provides detailed requirements for GFCI protection, including the locations where GFCI protection is required, the types of receptacles that can be used, and the testing and maintenance procedures that must be followed. It's important for electricians and other electrical professionals to be familiar with the NEC requirements for GFCI protection to ensure that their installations are safe and compliant. In summary, GFCIs are essential safety devices that protect people from electrical shock. They work by detecting ground faults and quickly cutting off the power to the affected circuit. While GFCIs do not require a ground to function, they are most effective when properly grounded. Electrical inspectors play an important role in ensuring that electrical installations meet safety standards and the GFCIs are properly installed and maintained. Firstly, always prioritize safety when working with electricity. Secondly, understand the function and limitations of GFCIs. Thirdly, follow the NEC requirements for GFCI protection. Fourthly, consult with a qualified electrician if you have any questions or concerns. If you are working with electricity, always follow safety precautions. Firstly, turn off the power at the circuit breaker before working on any electrical wiring or devices. Secondly, use insulated tools and equipment. Thirdly, never work in wet conditions. Fourthly, test all wiring and devices with a voltage tester before touching them to ensure that they are not energized. A GFCI tests for an imbalance in current. It does not need a ground trip. A GFCI monitors the current flowing through the hot and neutral wires. If the difference between the current going out and the current coming back exceeds a certain threshold, typically 5 mA, the GFCI trips, quickly cutting off the power. This imbalance indicates that current is leaking somewhere, possibly through a person who is touching a live wire. If you replace a 2-pole outlet with a GFCI outlet, you need to label it properly. Since there is no ground wire, you must attach a sticker that says no equipment ground. This alerts users that the outlet is GFCI protected, but doesn't have a ground connection. The tester is designed to send a small amount of current to ground. If there's no ground wire, the tester won't work. However, this doesn't mean the GFCI isn't working. You can still test the GFCI by pressing the test button on the outlet itself. This simulates a ground fault and should cause the GFCI to trip. The next, specifically section 406.4 D2, addresses replacing receptacles. It states that when replacing a non-grounding receptacle, it can be replaced with a GFCI receptacle. If you go this route, no equipment grounding conductor needs to be connected to the GFCI receptacle. Also, you're required to mark the receptacle with no equipment ground. This helps avoid confusion and informs users that the outlet isn't grounded. The test button on a GFCI outlet is a built-in test mechanism. When pressed, it creates an internal imbalance that simulates a ground fault. This should cause the GFCI to trip, proving that the device is functioning correctly. If the GFCI doesn't trip when you press the test button, it needs to be replaced. Many older homes don't have grounded wiring. In these cases, GFCI protection is especially important because it provides a level of safety that wouldn't otherwise exist. Even without a ground wire, the GFCI can still detect imbalances and prevent electrical shock. It is a common misconception to ground the ground wire of a GFCI to a cold water pipe. This is not what you are supposed to do and may not be a safe practice. If you want the protection of a ground wire, then you would have to run a ground wire from the panel. A GFCI is not a surge protector. A surge protector protects against voltage spikes. A GFCI does not protect against voltage spikes, it protects against current leakages.